Hello guys, today I want to show you how you can write a program that multiplies matrices of any size. Yeah, here we go. Open your compiler. So #include stdio.h, our standard input and output library, and then we go to the main program. Int main. Yeah. So we shall need variables. We shall need column, the number of rows for the first matrix, the number of columns for the first matrix, number of rows for the second matrix, number of columns for the second matrix. We shall need the count for the rows and the count for the columns. Then we shall need the count for elements. Yeah, from there, printf, enter number of rows and columns of the first matrix. Enter number of rows and columns of the first matrix, and this is the program that multiplies in two matrices. Oh, yeah. Now enter number of rows and columns of the first matrix, and then we enter them from the keyboard. Yeah. So we shall store them in R1 and C1. Yeah. And also we shall enter the number of rows and columns of the second matrix. So here we go. Enter number of rows and columns of the second matrix. So we shall prompt the user to enter them from the keyboard. So enter number of rows and columns of the second matrix, and then enter them from the keyboard. Yeah, from the keyboard. Yeah. We shall store rows in R2, that is row 2, row for matrix 2, and store columns in columns for matrix 2. Then we shall check for compatibility. Compatibility check. Now, if the number of columns for the first matrix not equal to the number of rows for the second matrix, then it is not compatible. So if the number of columns for the first matrix is not equal to the number of rows of the second matrix, return an error message. Return an error message. Yeah, sorry, matrices not compatible. Yeah, and then if it is not so, we shall go ahead, we shall multiply our matrices. So we shall enter the elements of the first matrix. Yeah, so we shall need to declare the two variables, the three variables that store the first matrix, second matrix, and the product. So we shall need matrix 1, it will take in R1 and C1. Then we shall need matrix 2, and it will take in R2 and C2. Then the product will take in row by column. Yeah, it will take in R1 and C2 probably. So now, yeah, I think we are there. Row by column, yeah. Now we shall enter elements of the first matrix. Yeah. Enter elements of the first matrix. And we shall use nested for loop. So for I equals to 0 to count for rows to I R1 rows of the first matrix, and this is an iteration of 1 1. Then for the columns, j equals to 0 up to j equals to c1. That is for the rows, for the columns rather, and it is j plus plus. So we shall have the elements of the first matrix A11. So we shall need A11, yeah, A11, and enter it. So this is I plus 1 due to the fact that I starts from 0, and we refer to j plus 1, yeah, to bring the sense of A11, not A00 here. Now after that we enter it from the keyboard, scan F, and it's a floating variable. Yeah, now it is percentage %F, and then store it in the first array. It is I j, yeah, and then we shall have to enter the elements of the second matrix. Yeah, so we shall enter them. So we are entering elements of the second matrix. And we shall use a nested for loop. So for I equals to 0 to I less than R2, and this is I plus plus. Then for j less than 0 to j, for j equals to 0 to j less than c2, and this is j plus plus, an iteration of 1 1. Then we shall need b. The elements are going to be called b. Yeah, and this should be each on a new line. Yeah, so it's going to be on a new line, each on a new line. and it's going to be called B11. Yeah, and we shall store them in this array matrix too. Yeah, I, J, and then enter them from the keyboard. Yeah, they are floating variables. Oh, sorry. Here I've made a mistake, a simple one. So we shall enter B11 like B0, B12, B23. So we shall refer to I plus 1 and then to J plus 1 due to the fact that all start from 0. So now we shall store them, we shall enter them from the keyboard and store them in the array called the matrix 2. So shall use Bij. Yeah. So now after we are going to multiply the matrices. So we shall need a nested for loop. At first we are going to fix the rows of the first matrix, and then yeah, we shall fix them rows of the first matrix. This is I plus plus, and then fix, we shall fix, yeah, and then fix the columns of the second matrix. So that is J equals to 0 to J less than column 2. J equals to 0 to J less than column 2, because we are fixing columns of the second matrix. That is J plus plus, and then we vary elements of the, we vary the elements of both the second and the first matrix. That can be that is J equals, no, from K, because the element position is marked by K. So from K equals to 0 to K less than column 1. Yeah. So this is K plus plus, and then we are going to multiply them. But first, the product of the matrices, the sum of those elements, we have to declare the sum, which is the same as 0. So sum is 0 at first before doing anything. So the sum is going to be sum plus the element in matrix 1. So remember, we are varying the rows of the first matrix. So we are fixing them. So this is I equals to 1 to J to K, then times, so we are varying them, times matrix 2 from K to J. Yeah. So after, we can store the sum in product. So product in Ij equals to sum. Yeah, and we can redefine sum as 0. Yeah, and now we can print the elements. So we shall use a nested for loop still. So print if, so we shall need a nested for loop from I equals to 0 to I less than R1. This is I plus plus, and then for j to j less than C2. This is j plus plus, and then we print. So we are going to print the elements. So it is percentage. We can take to one decimal place and then put a tab. So we are going to refer to product in I j, and then if we reach, so if j plus 1, if we reach the last element in a column, the last element in that row, we go to a new line. Then otherwise can go to a new line. Then the program is done. Return 0. Enter number of rows and columns of the first matrix 2 by 3, then 3 by 4. So let's see the compatibility. 2 by 3, then 4 by 5. Sorry, matrices are not compatible. Then let's try to multiply a 2 by 2 matrix. 1, 2, 3, 4, 4, 3, 2. So there we are. Thank you for watching.